Hi friends, welcome back. Good evening, good afternoon, good morning, whatever time of day you are deciding to watch these videos. So now we're diving into a brand new unit. We're getting into basically global circulation. And not only like globally, but we're going to talk about like localized winds as well. So in order to really like dive into these ideas, we need to first recall some basic physics laws, and because that's how we're gonna tell ourselves how the wind blows, is by doing that. So essentially, how we're going to be looking at air parcels are by the different forces that act on them in order to make them move. So there's basically three main forces that we're going to be talking about: the pressure gradient force, the Coriolis force, and frictional force. Kind of like I said before, if this gets a little bit wonky in terms of concrete ideas, I totally understand that. Just know that I'm here to help us work through it. If you're not getting it right away, hey, thankfully for you, at least some of these parts of the lecture material is recorded and on YouTube, so you can kind of watch it several times. So with all of that said, we're going to first consider Newton's laws. Newton, cool dude, I guess. I don't know, the apple fell on his head or whatever. Eureka. But pretty dope in terms of how he came up with his laws of motion. So if you recall, maybe you've heard of this law before. If not, guess what? It's all right. First time for everything. So if you do know it, think to yourself what it is. If you don't, maybe take a pause, because you probably heard it before, maybe somewhere in your educational career. If you haven't, hey, guess what? It's all good. So the first law of Newton's laws of motion is that an object at rest will stay at rest, but an object in motion will stay in motion at a constant velocity in a straight line if no net force is exerted on that object. So basically, if we're just sitting here doing nothing, right? No forces at all hanging out on my little ball here, then I'm going to stay still. But there's a really good point to make here on the right-hand side of this little drawn schematic, is that there are still forces acting on this ball, but none of them are overpowering the other one. So in this case, in this drawing, gravity is exerting a downward force for the ball into the table, and the table is exerting an upward force onto the ball. So those forces are going in equal and opposite directions, in a sense that allows the ball to not move. I'm sitting on my couch. The gravitational force is keeping me down into this couch, and then the upward force of this couch is keeping me in this cute little nooked corner I have made for myself to record these lovely videos. You can look around you, or maybe you're sitting in a chair, sitting on public transportation, wherever you're sitting. Gravity's keeping you down, whatever you're sitting on is keeping you up. Or standing. Maybe you're standing. I don't know. Maybe you're a stander. My boyfriend's a stander. He like literally stands all the time. It weirds me out a little bit. So that's the first law. That's the one thing to keep in mind, right? And if we were in space, if we were to like throw a ball in space, it would continue on forever and ever and ever, amen, until something else got it to veer off of its path. If you're into sci-fi movies or sci-fi films, or sci-fi anything, by the way, a really good show on Amazon Prime called The Expanse, and they go through the laws of physics really, really well, and they like really dive into that idea of like, oh, okay, if something is like moving and like spinning away, it will like continue to do that, and then it can make it impossible for you to retrieve that. That was Nubbins, by the way. She wanted to sniff my head for a second, and then now she's chilling over there. Anyways, so that's Newton's first law. Newton's second law, if you know this one, is related to an equation, which is that force, oh, sorry, just kidding. This goes back into that idea that with, if there's no forces acting on it, it will continue on in a straight line forever and ever, amen. Basically what I just said. And then also, considering gravity. Gravity is a force that's always acting on a ball. So, you know, I've had in class a couple times that bouncy ball that I kind of like bounce around or throw around all the time. So gravity is always acting on an object. Doesn't matter if it's acting on it while you throw something up, but also while it's coming down. So then these ideas lead to Newton's second law, which is the equation of force is equal to mass times acceleration. So the force that's exerted on an object is equal to the mass of that object times the acceleration that is produced by that object. So an object will always accelerate into the direction of the total forces acting on it. Total forces, that's like a really, really, really important point. So there can be multiple forces, and that's what we're really going to dive into when we talk about some of these forces here. Okay, so and like kind of even going back to like this gravity situation, or even like where you're sitting, right? The total number of forces that are acting on you while you're sitting or standing where you're at, you have the total force of gravity keeping you down and the total force of whatever you're sitting on keeping you upwards. Those are negated. You're not accelerating anything. Or you're not moving. Obviously we're moving, we're on a spinning planet, but you're not physically like right now moving. So that's kind of the main idea with Newton's laws. So what we're going to do is we're going to take these ideas and use them in a sense where we're now going to describe the types of forces that apply to air parcels. All right. So just to recap, Newton's first law: an object in motion stays in motion, an object at rest stays at rest. So that's basically the two main ideas of that. So you can have multiple forces going on. Gravity is always acting. Doesn't matter if an object is going upwards, gravity is always trying to pull it down. And then even when something's coming down, gravity is still trying to pull it down at the same time, right? But with Newton's second law, that tells us force is equal to mass times acceleration. There can be multiple forces, which is going to be the whole, basically, center of the next couple of videos. All right. Thank you so much for watching. Tune back in to talk about the pressure gradient force.